Starting off, it says sometimes you'll get the same factor twice. And how can we write something times itself?
Squared.
That's something squared, okay? These repeated roots are tied to a concept called, I want you to circle this or highlight it, multiplicity.
Okay. That's a big word.
Multiplicity is easy to remember. When I hear multiplicity, I think multiple. Like how many multiple number of times does it happen? So the multiplicity is the number of times that that factor occurs. So how many times does this factor occur?
Once.
Once. So I would say it has a multiplicity of 1. Okay? How many times does this factor occur?
2.
Twice. So I would say it has a multiplicity of 2. And what do we know happens when a factor happens twice?
It bounces off.
So you guys already know all this stuff. And x minus 4, what is the multiplicity of that factor? 1. Okay? So, let's tie this all together. What would my 0 be for this factor? X equals, remember, 0 is a solution.
X equals 2.
2. And the way I write it, I just put like a little m and then a colon. And what did you tell me the multiplicity was? 1. That factor only happens 1 time, so the multiplicity is 1.
How do you know it's 2?
Yeah, you set x minus 2 equal to 0. Just like the way you solve it. Yep. Okay, if I set x plus 3 equal to 0, what is my answer going to be? Negative 3. And you already told me the multiplicity was 2, because that factor occurs twice. And lastly, the very last 0 is 4. And what's the multiplicity of that factor? 1. So far, all we've had is crosses.
Yeah.
You did bounces on Desmos, but we haven't actually done it ourselves yet, okay? So go ahead and put those 3 x-intercepts on your graph. So we have 2, we have negative 3, and we have positive 4. And which one is going to bounce? The negative 3, right? So I like to put a B. A little right there, just right next to it, so you don't forget to bounce off of that intercept when you go on your little roller coaster ride.
Right.
Okay, a few other things you always need to find. What is the degree? What is the degree of this polynomial? 2. Remember, the degree, if you were to take the time to FOIL this whole thing out, what would your largest exponent be?
4. 2.
4. Really? This is x minus 2 times x plus 3 times x plus 3 again times x minus 4, right? So how many total x's are there? 4. Most importantly, it's even. If I FOILed all of those x's out, what would the leading coefficient be?
1.
A positive 1, right? Because there's nothing in front of, like if there was a 2, and I FOILed all these out, I'd get 2x to the 4th.
Right.
But they're all just 1 x's. So x times x times x times x, x to the 4th. So now we can figure out our end behavior. This is a positive even function.
It's a parabola.
It's a top. And the last thing you always need to find, what is the y-intercept?
Right.
And I honestly don't care if you throw this whole thing in your calculator, but what do you have to do? Put in zeros for all the x's. So 0 minus 2 times 0 plus 3, and then don't forget to square that. And then parentheses 0 minus 4. 72.
Wait.
No, that's okay. What I do, I'll put a little point up here, and let's call it 7. I'm going to cheat.
Yeah, that's not okay.
Okay, so watch me go on this roller coaster ride. I know it's a top, so I'm going to start at the top. I'm going to bounce. I'm going to hit my y-intercept. I'm going to cross, and I'm going to cross, and where do I end? Up. So, some of you might have asked, well, how far do I go down here? Do I go down this far? Do I go down this far? I don't know how far this goes down. So what you can do, I'm going to erase all of this. What number is between this point and this point? What is that x value right there? It's a 3, right?
Yeah.
So what you can do, and it's super easy, just like we plug in 0 for x to find the y-intercept, you can evaluate the function at 3 and see what the output is. So if I want to see how far it goes down, you just plug in 3 for all the x's. So then you just type it in all again, or you might already have it in your calculator. So I'm just going to plug in a 3 minus 2. And then I'm going to do a 3 plus 3 squared. And then I'm going to plug in a 3 minus 4. So negative 36. It actually goes down pretty far. So my graph was fairly inaccurate. It's more just like an estimate. Like I know the shape of it, I know if it bounces, but it actually goes way down. So if I was graphing this more accurately, it would actually go way down here to negative 36. So you can kind of hit it, and it makes quite a bit bigger loop than we thought it did. So that's a way you can kind of just go above and beyond what I expect, is to just get a few more points and really see how far those curves go up and down. Obviously, the y-intercept will give you one of them. And so usually there's just like 1 or 2 more curves you can throw in and see where the output is at. Okay, I want you to try and do example 6 on your own. You should have gotten 5 and negative 4 for sure, right?
Yeah.
Now some of you are overthinking negative x squared. That is a factor. If you set that factor equal to 0, you divide both sides by negative 1. Does that change 0?
No.
If you square root 0, does that change 0?
No.
No. So we get x equals 0. It's just another x-intercept. Anytime there's like a GCF of any x out front, it's just going to be 0. Okay, what was the multiplicity of 5?
1.
What was the multiplicity of negative 4?
1.
What about this one, though?
2.
Yeah, that x was squared. So when you put these on your graph, you're going to have positive 5, you're going to have negative 4, and 0 was x squared. That's going to be a bounce. So I like to label that so I don't forget. Okay, now some things you need to think to yourself, or you can write it down, the degree. If you were to FOIL this whole thing out, what would your largest exponent be? In other words, add up all the x's.
Negative 4.
It would be x to the 4th. We don't have negative degrees yet, so it would be 4. But yes, the leading coefficient would be what? It would be negative because of that negative in front. So this is a negative even degree. It's a negative leading coefficient and an even degree. So even degrees are like quadratics. What do negative quadratics do?
They go down.
Down, down. If you plug in 0 for all of your x's, what's the y-intercept going to be?
0.
Yeah, we already knew that because the x-intercept is 0. If the x-intercept is 0, it has to cross the y-axis at 0 as well. So the y-intercept is 0. Now what I suggest doing is figuring out how far it's going to go up between here and between here. So what's a number we could plug in between here on the left side?
3.
Negative 2. Let's do that. So in your calculator, so type in negative, and then x itself is negative 2, so you need to put that in parentheses. You might want to look how I'm typing this in calculator. Squared times negative 2 plus 4 times negative 2 minus 5. Okay, enter. Goes up pretty far. Yeah, most of these are going to be off your graph. So what you can do for kind of like level 4, at negative 2, I know we go up to 56. And then what's a number I can plug in between 0 and 5?
3.
3, sure. You could plug in 1, you can plug in 2, you can plug in... I like to pick something in like the very middle, so you can either plug in 2.5 or 3. So once again, the negative is not part of the squaring. That's negative 3 squared times 3 plus 4 times 3 minus 5. Woo! It goes way up. Over 3, up 126. So now I'm going to cross, hit my 56, bounce, hit my 126, and end down.
Nice.
All right, so once you determine the end behavior, we need to factor. This is where it all comes together. How do I factor something with 4 terms?
The pairs.
Factor by grouping. You guys bring the talking down. Split it in half. What's the GCF of the first half?
X squared. Yeah.
Which leaves behind 2x plus 3. What's the GCF of the second half?
-4.
Which leaves behind
2x plus 3. Whoa.
the next step of grouping. That repeated factor comes out front as a GCF, like a GCF of the GCF. And what's in between?
X plus x squared minus 1.
Okay, one of those can factor again. What is x squared minus 4?
X plus 2, x minus 2.
And obviously 2x plus 3 is done. You can't break apart any further because it's down to a single x. Alright, so my x-intercepts are negative 3 halves, negative 2, and positive 2. So you can go ahead and throw those on your graph. Negative 2, positive 2. What's negative 3 halves?
Negative 1.5.
Negative 1.5, so those are pretty close together. What is the multiplicity of each of them? Yeah, they're all just a multiplicity of 1 because none of those factors are squared. None of them are. So the multiplicity is 1 for each of them.
Yes.
A few more things that we could, so that's the hard part, is factoring and solving. We know the x-intercepts. Now we just need to kind of make our graph a little bit more accurate. So some things that you can do, find a y-intercept. So if you go back to the original function, if you plug in 0 for all of the x's, what's my y-intercept? Negative 12. I'm going to go ahead and write it as a point. So over 0, down 12 is the point 0, negative 12. That's just a little bit off your graph. You can put it down here. There's negative 12.
How's it supposed to be a line?
Okay, now what?
Well, it's really.
This y, can you see how this y-intercept is between these 2 points?
Yeah. Yes.
So we already know how far it goes down there. If you really wanted to, you could plug in like negative 1.75 to figure out how, obviously it's not going to go up that far because that's such a tiny little gap. So I'm just going to not do that, if you don't mind.
Don't do it.
So here I go on my roller coaster ride. None of them bounce, right?
Right. No.
So I start at the bottom. Cross, cross, hit your y-intercept, cross, and you should end up. So first of all, what should we always do first?
Yes.
GCF, good job. Which leaves behind x to the 4th minus 1. Okay, take it from there. So here's the factors. Now, does 6 give me an answer? Is there an x attached to 6?
No.
No, you only get an answer if there's an x, right? X has to equal something. So 6 is nothing more than a GCF. And then x equals negative I. X equals positive I. We're out of time.